Swayam Prabha. Digital India. Educated India.
Now, let us start with another idea is called it as agents and environments associated with AI and ML. So, what is an agent? An agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So, the simple idea is illustrated in the following figure. This is the agent interact with the environment through the sensor and actuator. So, the domain is a agent and we have to sense about that. So, it goes to the actuators, and sensor actually comes from the environment and it is actually percepts, and it goes to sensor and then actuator, and then we have to take action. Once again it goes to environment. So, this is the pictures demonstrated with the meaning of agent and environment. So, we use the term percept to refer the agent's perceptual input at any given instant. So, an agent's percept sequence is a complete history of everything the agent has ever perceived. So, the agent can perceive the environment to the agent, and internally the agent function for an artificial agent will be implemented by an agent program. So, it is important to keep these two ideas distinct. So, the agent function is an abstract mathematical description. So, agent program is a concrete implementation running within some physical system. So, illustrate these ideas, we use a very simple example, the vacuum cleaner world shown in the figure. So, this world is so simple that we can describe everything that happens. It is also a made up of world. So, we can invent many variations. This particular world has just two locations, one is a square A and B. So, the vacuum agent perceives which square it is in and whether there is a dirt in the square. So, it can choose to move left, move right, suck up the dirt or do nothing. So, one very simple agent function is the following. So, the current square is dirty, then see this is the picture shows that the cleaning of the water spaces, and then this is a vacuum cleaner and two location is there, and one is A, another one is B, and there is a picture demonstrated the cleaning of the platform or the cleaning of the floor or cleaning of the wall or the ceiling, or see these are all the spaces to clean that. So, this square is dirty, then the cleaning will be is a following sequence. This is the mission design. So, A first clean in the right action right, and then if it is dirty then it will be suck, and once again it will suck and clean, that is B, and it goes to the left, and left it moves, and then you go to the right and if it is dirty or not. So, the B is once again sucking that dirt from the floor, and then it will move to both A clean and A clean in the right as well as A clean and A dirty in the sucking of the ideas. So, these are all the process you have to design. So, this is the pattern of the sequence you have to design. So, first A clean, A dirty, B clean, B dirty, then A clean, A clean, and A clean, A dirty, and so on, A clean, A clean, A clean. So, next 3 times it goes, and then next pattern is clean, clean, dirty, and then if it goes to the right then go to the suck, and then move to the fourth ideas A clean, A clean, A clean, that is B clean, be clean and be clean, be dirty, like that it goes. So, that way it moves that. So, this is the pattern you have to defaultly supply to the agent. So, this is a partial tabulation of a simple agent function of the vacuum cleaner, and shown in the figure 2.2 back. This is a technique we have to implement, so that artificially it will do that. So, presently in our foam we are using these ideas because of these structures. And next we are going to discuss the rationality. What is a rational? At any given time depends on the 4 things. One is a performance measure that defines a criterion of success. Next one is the agent's prior knowledge of the environment. Third, the action that the agent can perform. And fourth, the agent percept sequence to date. So this leads to the definition of a rational agent. For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever may be the built-in knowledge the agent has. So, consider the simple vacuum cleaner agent that cleans the square if it is dirty and moves to the other square if not. This is the agent function tablet in the figure 2.3, this is the 2.3, and then is this a rational agent? That depends. First we need to say what the performance measure is and what is known about the environment and what sensor and actuator the agent has. So, let us have the following statement. So, the performance measure award 1 point for each clean square at each time step over a lifetime of 1000 time steps. So, the geography of the environment is known priori, but the dust distribution and initial location of the agent are not, and clean squares stay clean and sucking cleans the current square, and the left and right action move the agent left and right except when this would take the agent outside the environment, in which case the agent remains where it is. So, the only available actions are left, right and suck. So, the agent correctly perceives its location and whether the location contains dirt. So, this is the inbuilt default function you have to do that. Then the vacuum cleaner, how artificially it works, that we can understand. Now, we have to specifying the task environment. In our discussion of the rationality of a simple vacuum cleaner agent, we have had to specify the performance measure, the environment and the agent actuators and sensors. So, we group all these under the heading of a task environment. For acronomically minded, we call this as PS. So, the acronymic says that P for performance, E for environment, A for actuators and S for sensors description. So, in designing an agent, the first step must always be specify the task environment as fully as possible. So, the following figure summarize the performance, environment, actuators, sensors description for this taxis task environment. We discuss each element in more detail in the following paragraphs. Agent type, performance measure, environment, actuators and sensors. First, agent type is a taxi driver is a agent type. Now, what are all the performance we have to measure, whether it is a safe and fast, legal, comfortable trip, maximize profits. So, these are all the performance measure. Next, we have to following the environment is located. One is road, other traffic, pedestrian, customers. So, these are all the environment. Next, actuators means the steering, accelerator, brake, signal, horn, display. So, next sensors, camera, sonar speedometer, and then GPS, odometer, accelerometer, engine sensor, keyboard. So, these ideas you know that, then we can easily describe the AI of working of the taxi. That is taxi, without a taxi driver we can run a car, and this is a technique we have to do that. So, that PEA's description of a task environment for an automated taxi will work. So, the range of task environments that might arise in AI is obviously vast. So, we can however identify the fairly small number of dimensions along which task environments can be categorized. These dimensions determine to a large extent the appropriate agent design and the applicability of each of the principal families of the techniques for agent implementation. First, we list the dimension, then we analyze the several task environment to illustrate the ideas, and next the definition here are informal, and the later chapters provide more precise statement and examples of each kind of environment. Now, these are all the examples of agent type there, performance, environment, actuator and sensor description. Further, for the medical diagnosis system, agent is medical diagnosis system. Then the performance measure is health patient reduced cost. For the environment, patient should be there, hospital staff should be there. So, these are all the ideas for the environment. Next, actuators is a display of questions, test, diagnosis, treatments and referrals. Sensor is keyboard entry of symptoms, finding, patients, answers. Next, agent, satellite image analysis system. So, what all the performances are? Correct image and then characterization. Next, environment, downlink from the orbiting satellite. Third, actuator is a display of skin categorization, and fifth one is sensor color pixel arrays. Next, agent type is part picking robot, right. So, performances are percentage of parts in correct bins. Environment is conveyor belt with the parts bins. Actuator is a jointed arm and hand. Sensor is camera, joint, angle sensors. Next, agent type is refinery controller. Performance measures are purity, yield, safety. Environment are refinery operators. Actuators are valves, pumps, heaters, displays. Sensor are temperature, pressure, chemical sensors. Next, agent type is interactive English tutor, and performance measure are student score on test, and environment set of students testing agency. Actuators are display of exercise, suggestion, correction. Sensors are keyboard entry. So, based on this we can design the AI. So, if you want to design AI, we need PEAs. PEAs mean performance, environment, actuators and sensors. So, these are comes under the what agent that we can easily display. So, all are mathematically design the tool, so that a person know the pattern and then that sequence based on the a sensor we can easily do the AI. Next, as one might expect, the hardest case is partially observable, multi-agent, stochastic, sequential, dynamics, continuous and unknown. So, these are all the things are expect. Now, you go to the taxi driver. So, taxi driving is a hard in all these senses except that for most part of the driver's environment is known. So, driving a rented car in a new country with unfamiliar geography and traffic law is a lot more exciting. So, figure 2.6 lists the properties of number of family environments. Note that the answer are not always cut and dried. For example, we describe the part picking robot as episodic because it normally considers each part in isolation. But if one day there is a large batch of defective parts, the robot should learn from several observations that the description of defects has changed and should modify its behavior for subsequent parts. So, we have not included a known or unknown column because, as explained earlier, this is not strictly a property of environment. For some environment such as chess and poker, it is quite easy to supply the agent with a full knowledge of the rules, but it is nonetheless interesting to consider how an agent might learn to play these games without such knowledge. So, once a person is know the chess and poker, also they can understand how the agent is associated with the PEAS. So, these are all the part of the AI, and once this is the layman study, and then you have to go to the depth of the AI. So, this is the picture we demonstrated. So, task environment are observable agents, whether it is a deterministic or not find out, and episodic or not find out, whether it is a static or dynamic that you have to find out, and then next you have to whether it is a continuous or discrete, therefore discrete you have to do. Now, you take first one, crossword puzzles and chess with a clock. This is a game, you know crossword puzzle, you know gaming chess with a clock. So, everything is fully observable, therefore they are fully observable, and then whether the crossword puzzle is a single person playing or multi-person playing, that you have to check it out. Therefore, crossword puzzle is based on single, therefore agent is single. For chess we need two people, therefore chess with the clock, therefore it is a multi-agent. And crossword puzzles is based on the deterministic, therefore we have to write the column of deterministic. Then whether it is a sequential order or not, that you have to check it out. So, therefore that is called it as episodic. Now, it is a static or dynamic, so it is a static, and whether it is a continuous or discrete, it is a discrete, because one person play, rest of them keep mum, and then other people play and rest of them keep mum, that is therefore it is a discrete. Similarly, for chess with the clock is fully it is observable, it is a multi-agent, and it is also deterministic, and it follows the episodic is a sequential, and static is a semi, and then it is also discrete. Next game is poker and backgammon, one of the task. So, it is poker is a partially observable, it is a multi-agent, and it is a stochastic ideas. So, there is a deterministic, stochastic are the two different ideas, because stochastic is based on the probabilistic technique, therefore it comes under the stochastic, and episodic is a sequential, and it is a static and a discrete. Backgammon is a fully observable, it is a multi-agent, and it is also stochastic, and episodic is a sequential, and also it is a static, and it is also a discrete task. Next, taxi driving. Taxi driving, suppose you take a car and driving a taxi is a taxi driving, and then it is a partially observable, because a person start from one point and then a fully remote area it goes, therefore partially it is observable, therefore and followed with satellite it is a multi-agent, therefore it is stochastic, and episodic is a sequential, and static is a dynamic, and also it is a continuously moving from starting to the ending point. Similarly, for medical diagnosis for a man or any living things, if you are analyzing the medical, then it is a partially observable, because initially you are checking the condition of their body health and then you started to give the medicine, after that only it is observed. So, partially only you have to observe and rest of them leave it to that, then you have to check. And it is also a single agent, because single person only having the disease to and check the doctor is a AI, therefore that you have to do the single, and it is a stochastic and a sequential, dynamic, and it is also continuous. Next, image analysis. Image analysis is fully observable and it is also single agent, and it is a deterministic and episodic, semi and continuous. Next, part picking robot is a partially observable and it is also single agent, and it is a stochastic, and it is a episodic, and static is a dynamic, and discrete is a continuous. Next, refinery controller, it is a partially observable, it is also single agent, it is a stochastic, and episodic is a sequential, and it is a dynamic, also discrete is a discrete or continuous, it is a continuous. Next, interactive English tutor. Interactive English tutor mean teacher is interacted with the student, but here the teacher is a AI on mission, then interactive English tutor is a partially observable and it is a multi-agent and stochastic, whether it is a sequential, episodic or not, check it out, and dynamic or static, you check it out, it is a dynamic, and also it is a discrete. So, this is the example of task environment and their characteristic. Next, structure of agents. So, for we have talked about the agent by describing the behavior. So, the action that is performed after any given sequence of percepts. Now, we must bite the bullet and talk about how the inside work. So, the job of AI is to design the agent program that implements the agent function. So, the mapping from the percepts to actions. So, we assume this program will run on some sort of computing device with a physical sensor and actuators. So, we call this the architecture. So, agent is nothing but architecture plus program, that is called as a agent. Now, we are going to discuss the agent problems. So, we describe the agent problem in the simple pseudocode language that is defined in the appendix. For example, figure 2.7 shows a rather trivial agent problem that keeps track of the percept sequence and then uses it to index into a table of action to decide what to do. So, this is the online code repository, contains the implementation in a real programming language. So, the table an example of which is given for the vacuum world in the figure 2.3 represents explicitly the agent function that the agent program embodies. So, to build a rational agent in this way, we as a designer must construct a table that contains appropriate action for the every possible percept sequence. So, this is the inbuilt ideas: function, table driven agent, percept. That is, you have to mention returns an action, and persistent is a percept sequence initially empty, and table comma a table of action comma index by percept sequence comma initially fully specified. So, these are all you have to type it and append percept to the end of percepts action arrow lookup percepts comma table you mentioned return action. So, this is a inbuilt, you have to mention what you are going to design, so that the program will come. Now, this is the figure shows that this is the table driven agent program. Is a new percept, a return an action of each time. So, it retains a complete percept of sequence in memory. In the remainder of this section, we outlined 4 basic kinds of agent programs that embody the principles underlying the almost all intelligent system. Number 1 is simple reflex agents, model based reflex agent, goal based agent, and utility based agents. Now, this is the schematic diagram of agent to environment, environment to agent. So, agent first you have to take, that makes with the sensor, and then the sensor is based from the environment, and then once you censored what the world is like now, that it will test that ideas from the sensor. So, what action we have to take? So, that action taken and should now implement, and then it will go to the actuators, and once again it goes to environment. If you put the condition of action, then condition action rule you have to implement, then it takes into account of action, and then it will go to the actuators. The actuator reflect to environment, the environment reflect to sensor, like that cyclically it goes. So, this is the diagram of simple reflex agent. So, this is the inbuilt function, simple reflex agent percept returns an action, persistent colon rules comma a set of condition hyphen action rules, state you have to interpret what input percept, rule match state rules, action rule action return action. So, this figure shows that simple reflex agent, it acts according to the rule whose condition matches the current state defined by the percept, the process. So, the agent program, which is also very simple as shown in the figure. So, the interpret input function generates an abstracted description of the current state from the percept, and the rule match function returns the first rule in the set of rules that matches the given state description. Note that the description in terms of rules and matching is purely conceptual. So, actual implementation can be as simple as collection of logical gates implementing a Boolean circuits. Next, model based reflex agents. Updating this internal state information as time goes by requires 2 kinds of knowledge to encoded in the agent program. First, we need some information about how the world evolves independently of the agent. For example, that an overtaking car generally will be closer behind than it was a moment ago. Second, we need some information about how the agent own action affect the world. For example, when the agent turns the steering wheel clockwise, the car turns to the right, or that after driving for 5 minutes northbound on the freeway, one is usually about 5 miles north of where one was 5 minutes ago. So, this knowledge about how the world works, whether implemented in a simple Boolean circuits or in complete scientific theories, is called model of the world. So, an agent that uses such as model is called model based agent. So, this is most important, this topic, agent and environment, and we are designing presently the AI on the road, how it is driving and going, and this inbuilt you have to do that, and superbly it works. So, the figure 2.11 gives the structure of the model based reflex agent with the internal state, showing how the current percept is combined with the old internal state to generate the updated description of the current state based on the agent's model of how the world works. So, agent program is shown in the figure. The interesting part is the function update state, which is responsible for creating the new internal state description. So, the details of how the models and states are represented vary widely depending on the type of the environment and the particular technology used in the agent design. So, the detailed examples of the model and updating algorithm are designed here with the help of the picture. So, the model based reflex agent, that is, one is agent, another is environment, we know that. So, we have to first with the help of the environment we have to find out the sensor. So, the sensor immediately sensed and then it goes to the question, and the question may be what type of the state, how the world evolves, what my action to do. So, these are all the question combined together, and then what the world is like now. And once these questions rise, it will go to the another question, what type of the action we have to be taken, and the action is based on the condition action rule. So, once you taken the action and then it will go to the actuators. The actuators will reflect to the environment, and once again they are cyclically going on. Therefore, this is called as model based reflex agent. So, this is the inbuilt function. First you write the function, and then model based reflex agent is a percept, returns as an action. Next, persistent state, the agent's current conception of the world state model, a description of how the next state depends on the current state and action rule, a set of condition action rules, action, the most recent action initially none, state, update the state, rule, match, action, rule, and then action, return, action. So, this is the picture based on the model based reflex agent. It keeps track of the current state of the world using an internal model. It then chooses an action in the same way as the reflex agent works. So, as an example of a taxi may be driving back home, and it may have a rule telling it to fill up with the gas on the way home unless it has at least half a tank. Although driving back home may seem to an aspect of the world state, so the fact of the taxi destination is actually an aspect of the agent internal state. If you find this puzzling, consider the taxi could be in the exactly the same place, but intending to reach in a different destination. So, this is the mathematical idea we are implementing in the AI.